Go to example 9. I explain it slowly. We will have a archaeologist here that's going to look for fossils. On average, you have got 10% of the rocks that will have a large number that contain fossils. They then say that they're going to select a sample of 25 rocks from the area. Actually, before I read the question, I already will suspect this is your trial, because the word after the number is likely to be the trial. It's up to you to confirm later on. And immediately on the next statement, I can confirm because they say number of rocks. This is a confirmation that they are telling you rocks is your trial. Success is the contained fossils. This is denoted by X. Let's show this probability division is going to be this expression. So we start the problem by writing down the distribution of X first. No need to define because they already defined the X. So X follows binomial 25. P is 0.1. Okay, we do it slowly. I'm going to tell you later on why they want this particular expression. Okay, so let's start with Px is k plus 1 divided by Px is k. You have no choice but to apply the binomial formula because of unknowns that appear like k and k plus 1. So we force ourselves to go for this by applying the formula. Formula is 25 choose k plus 1, 0.1 power k plus 1, and 0.9. The other power is always the subtraction of these two values. Take 25 minus your k plus 1. It will be 24 minus k. Divide 25 choose k, 0.1 k, and 0.9 25 minus k. Can we simplify the indices first by comparing the similar terms? 0.1 has a larger power at the top by 1. So 0.1 k plus 1 divided by 0.1 k, you will be left with 0.1 at the top. 0.1 is larger by 1 degree at the top. 0.9 is similar. Who is bigger? The denominator is bigger by 1 in the power. So I expect the division to give me 0.9 in the denominator. And now we continue. Unfortunately, you still have that choosing term. Let me write for you the formula. I write it above. Formula list has a n choose r formula given by n factorial, r factorial, and n minus r factorial. You use that formula to open up both n choose r's. So at the top, we get 25 factorial, k plus 1 factorial. Subtract 25 minus k plus 1. So you get 24 minus k. Denominator similar. We will immediately have got a cancellation. 25 and 25 factorial cancels out. You will then need to move this denominator to go up. So can I write it on the next line? 0.1 over 0.9 is 1 over 9. We move as per my red arrow and I regroup in this manner. Let's recall how you should simplify factorials of similar terms. Let's start with the easier term. Think about these two factorials, who is larger and who is smaller. The larger term is the k plus 1. always open up the larger factorial. We recall this formula. K plus 1 factorial can be written as K plus 1 multiplied to K factorial. Okay, I can always open up the bigger factorial, becoming K plus 1 times K factorial. The other term is similar. The bigger factorial is at the top. 25 minus K, I can change to 25 minus K times 24 minus K factorial. And 24 minus K factorial maintains below. Again, it will create for us a cancellation. And we are done. So it's 25 minus K. And you have 9 K plus 1. So maybe I just point out first, we have done the show. But how come their K is 0 to 24? Why not 0 to 25 since the largest K is 25? It's because if you substitute 24 into the top expression, you will get x is 25. And your x cannot exceed 25, maximum is 25. So they must say it's up to 24 only because of that reason. We are done with the show. Let's do the next part. They say, hence, can you consider this number or this expression? Find me the most probable x. What does most probable x refer to? Visually, we are going to think of the following. When they say most probable x, you are really going to think through who is the largest. That means if I compare all the different probabilities, all these are the probabilities, find me the highest one. Who is the highest? Give me the x that will have the highest probability. That's what they are looking for. Most probable means highest probability. Okay, we start the consideration with what they are looking for. This will be clear after one step. They ask you to start this way. X is K plus 1 to be larger than X is K. Why is it a hence? How to use this to link back to the previous part? You divide the right-hand side over. And this is because after I have divided the right-hand side over, your left-hand side is the expression that we have found for the show. This is the one I want. I have shown that is this. Use part 1 to put this back into the equation. We simplify this inequality by moving this denominator over. So let's think of this now. Okay, this is the crucial part that you need to try to understand. What does this imply? K is less than 1.6 means K can be 0 or 1. I'm going to write on the right-hand side, but I let you know also this is optional. What will happen at K is 0? You try to put this number back to the equation. Sub back to the equation to understand what it implies. So it is trying to say when K is 0, if I sub back, means X is 1 is larger than X is 0. I put back to the equation. If I put 1, it means X is 2 is larger than X is 1. Can I draw you a bar chart first on the probability? Just help me construct like a graph where I would like to have probability against X so that we see this visually. What is this probabilities trying to say? It is trying to say that 1 is larger than 0, 2 is larger than 1. So if I have probability against X, let's say 0 is a small bar, I expect 1 to be a larger bar and 2 to be an even higher bar. We don't know how high, but I know this is the current relationship on probability. 2 is higher and is sequentially higher now. So I can conclude also from these optional steps that X is 2 will be larger than X is 1, will be larger than X is 0. 2 has got the highest probability. The question now is, how do we know what happens from 3 onwards? I can only know 0 to 2, who is the largest? 2 is the largest. So here you need to know a second technique. In order to create k values from 3 onwards, the technique is to switch this inequality. We tested for more than, can we switch the inequality to make it be X is k plus 1 less than X is k? Swap the inequality condition that you used in the first portion, switch it to less than. Now, do you need to resolve the problem? If I change this inequality here, even if I resolve the whole thing, it will just mean that this will be swapped. It will surely be that I'm only switching the inequality, nothing else changed. So I am certain I will get k is more than 1.6 without doing anything. We're just switching the answer. So what kind of k values are we saying here? This is k is 2, 3, all the way to 24. The k values they gave for 24. Now this time, again, we sub back these values to the equation. Put back to that first line. So when k is 2, let's just write down, it means that x is 3 is less than x is 2. I sub 2 back. Let me just sub one more value. So 4 is lesser than 3. Who is the largest of all these numbers? 2 is bigger than 3. 3 is bigger than 4. So 2 is still bigger, sir. So if I draw on the bar chart, what will happen? If it's 3, 3 must be smaller than 2. 4 must be smaller than 3. These will actually keep continuing up to the last number at 25. You're going to see something like that. Okay, so the conclusion that we can draw from here will be still 2 is larger. 2 is larger than 3, all the way to the last number, which is 25. So what can you conclude from the two last concluding statements? I can conclude, therefore, not P. X equals to 2 is the most probable. You provide them with the X value because they ask you who is the most probable X. The most probable X is 2. Before you try, I want you to know what is important. The question guided you by giving you this consideration statement. Okay, they need not tell you this. You must know to start with this. Okay, so they can just omit this altogether and say, can you find me the most probable X? You must know to start with this statement. Actually, what does this statement mean? What do they mean by k plus 1 more than k? They are actually asking you to check on the number line on the bar chart. When is this going to happen? When is the k plus 1 bar higher than the k bar? They are asking you to do this check to understand that the solution will be at 2. So you start this way, even if the question didn't guide you to do so for the most probable. Okay, that's step one. Then step two, just flip the inequality. It will give you the other range of values that you're looking for. From a more than, we flip to less than. And last, this bar chart is important. You need to understand this is true for any binomial. When you have a peak at the most probable, the values will always continue to slope downwards. It gets lower and lower towards the left and right. It always slopes down from the peak. This is true for any binomial distribution, which you're going to see a similar graph next week when you solve for other problem types.